So we have, for the last couple of episodes, argued that torque and angular momentum were actually vectorial quantities if the direction of rotation, if the axis, even if it's translating, is remaining parallel to itself. We haven't really needed, strictly speaking, the vector character of these angular quantities. But today, it's time to be amazed. So we're going to talk about what happens when a torque, being a vector, decides not to point in the same direction as the angular momentum. And we'll see that this equation, which we have been developing, and in fact, if we were to take a different approach, we started by spinning things around and doing collisions, just an exact analogy with shoving things on air tracks and having them collide, and looking at what was conserved. But another approach would be to say, after working up F equals ma and understanding that we can sum over all the constituent parts, we could have just taken the cross product of that sum with the vector from some origin. R cross that F equals ma stuff. And on one side we would get torque, and on the other side we would get the time rate of change of something which we would end up identifying as angular momentum. So it doesn't have new physics if we're willing to go at it from that direction. But the important thing for today is that the direction for the angular momentum and the direction of the torque may not coincide, and that may lead to some very interesting behavior. This is a little graphic showing gyroscopic precession, much of the topic for today. And that has significant impacts on things like climate, which we'll talk about towards the end.